just now we did about the critical numbers, okay? And then we learned about the definition for the critical number. This is a remark, okay? We just need to know, okay, the remark, okay? It says, if f has a local maximum or minimum at C, then C is the critical number of f. Why this remark is true? Local maximum, local minimum, right? Give us what? So for example, this is C, this is what? At D. Because we know at local maximum or local minimum, okay, if we do tangent line to the curve at this local maximum, local minimum, we'll have horizontal tangent lines, right? Horizontal tangent line give us what? Zero slope. Slope comes from the derivative. Okay, so that means at the local maximum or minimum values, at the local maximum or minimum, we'll always have what? The derivative equals 0, right? And then we call the definition for critical numbers. If the derivative of f at C or D equals 0, the C or D is what? Our critical number. So that's why as long as we have a local maximum or local minimum at C, C must be a critical number of f. Why? Because f prime of C is what? 0. You guys understand that? Okay, so this is remark, you just know that, okay? Yeah, you just know local maximum, local minimum give us critical numbers, okay? Those C and D, those C values give us the critical number because the derivative at those numbers give us is what? 0. Okay, 0. Alright, so this is a remark. Now we're going to look at a closed interval method. Okay, so I'm going to ask a volunteer to read this method, then we'll try one question in class. Okay, Simon, can you read?
The closed interval method. Define the absolute maximum and minimum values of a continuous function f on a closed interval AB. Find the values of f of the critical numbers of f and AB. Then find the values of f of the endpoints of the interval. And the larger the values from steps 1 and 2 is the absolute maximum value, and the smallest of the values is the absolute minimum value.
Okay, very good. Okay, so I will also give you one question, at least the one question in your exam 3, to let you find the absolute maximum and minimum values of a function at a given interval. So be prepared, okay? Be prepared. All right. So it says, find the absolute maximum minimum of the function on a closed interval. What do we do at first? Find the values of f as the critical numbers. Why? Because on a closed interval, say a to b, see for example a to b, extreme values, okay, extreme values may happen at the endpoint, or it may happen in the middle of the endpoint, right? So if the extreme value occurs at the endpoint, so we can find the value of f at the endpoint, right? So we can, and compare in later. Okay, so endpoint is something that we need to check for f. Okay, or if the extreme values happens in the middle of the interval, what do we do, guys? We are going to what? Remember local maxima. Values of f are the critical numbers. Okay, critical numbers means what? In the middle of the curve, in the middle of the interval, it gives us what? It gives us critical numbers of f give us prime, right? The derivative equals 0. So local maximum, local minimum may also be what? The absolute maximum or absolute minimum. We don't know. So in order to find what is the absolute maximum or minimum value, okay, on the entire interval. So we should check what? We should check either at the endpoint whether we have the largest value or the smallest value, or we're going to check in the middle. How to check the middle? Find the critical numbers by what? Compute the derivative of the function, let it equal 0, or what? Let the derivative does not exist, okay? That gives us critical numbers, okay? And at critical numbers, we may get local maximum, local minimum. And that local maximum, local minimum might be what? The absolute maximum or minimum. Guys, do you see that? So, to find extreme value, what do? Follow the steps, okay? Then the third step, compare between the first two steps and find what? The smallest value and the largest value for the minimum and maximum, absolute minimum and minimum. You guys, do you see that? Okay, so let's just look at question A. I don't think we have time to do question B, okay? So let's do question A. Find the absolute maximum minimum of f on this interval, this. Okay, how? Step 1, find critical numbers. How to find critical numbers? Remember just now we did 2 examples about finding critical numbers. How? Differentiate it. Let it equal 0 or does not exist, okay? So differentiate f prime. How about you guys tell me? How to differentiate this? (6x squared minus what? 6x minus 12, right? Do we have any denominator? No. So there's no chance that the derivative will be does not exist, right? So we're going to let what? The derivative equals what? 0. Then we can find the critical number, right? Critical number. So how do you solve for this equation? So x will be what? Either when x equals 2 or when x equals what? Negative 1. Okay. So that means this function may have, will have what? Local maximum, local minimum at these values. But we don't know whether they are local maximum or local minimum. We don't know. Okay. We have to check. How to check whether the f value is maximum or minimum or anything else? What do we do? Find it, plug it in. So let's find f of 2 and what? F of negative 1. Plug in the x by 2 and negative 1 into the original function, please. And pay attention to the order of operation. I'll let you tell me what you get. Okay, f of 2 equals what?
Negative 19.
19? Negative 19? Agree with Stephen?
Yeah.
How about f of negative 1? Well, 8. Okay, so that means, in between of negative 2 and 3, we find, f of negative 1 equals 8, f of 2 equals negative 19. These are potentially, might be our extreme values, okay, so might be. But extreme value may also happens at the endpoint, right? So step 2, what do? Evaluate it as a function at what? F of negative 2 and f of 3. So please do this one as well. Plug in x by So what's your f of negative 2? Have you done? Negative 3? How about f of 3? Negative 8. Negative 8?
Is it positive or negative 3?
This is a 3 times positive 3, right? Endpoint, well, x equals negative 2 or 3, positive 3. So 2 times 3 to the cube minus 3 times, 3 squared minus 12 times by 3 plus 1. You get negative 8?
Yeah.
I read again, negative 8? Okay, so, let's see. My bad, this is 2 times, sorry. 2 times by 27, right? 54 minus 27 minus 36 plus 1. That gives us negative 8. Alright, so now we have these values. Let's compare which value is the largest value among these values. Which one? Negative 19, 8, negative 3, negative, what is the largest value? 8. What is the smallest value among these 4 values? Negative 19. Okay, so we say f of negative 1 equals 8 give us what? Absolute maximum value. F of 2 equals negative 19 give us absolute what? Minimum value. Okay, you guys? Okay, so this is just question 1. Okay, we follow the steps. Okay, find critical numbers because that may give us the local maximum, local minimum, and then we may have an absolute maximum, minimum, we don't know, okay? So that's why we check the critical numbers. Then also check the values of f at its endpoints. Then we compare among those values, which value is the largest, which value is what? The smallest. Then we get the absolute maximum and absolute minimum value. You guys?
Yeah, can you show us how to differentiate?
I don't think we are able to do this. I will leave this question next time for a longer times, and then I will do this question, it may take 15 minutes to do this. So, yeah. If you want to check, I write this down on the screen paper, you can check it here, okay? But I would leave a longer time for this question. I would say, leave this question on Wednesday. We'll do this together, okay? Yeah.